Okay, so welcome. I'm going to introduce to you stacks in this video as well as applications of stacks. So basically, this series of lectures are going to be on stacks complete stack playlist. So the first video would be introduction to stack. So what is stack? Stack is basically a LIFO data structure. So what is LIFO? Last in, first out. The element that has been inserted last would be deleted first. Therefore, insertion in stack is called push and deletion is called pop. So for example, let us take a stack like this, just a stack. So before going to stack, you can imagine stack basically as a stack of books, right? As a stack of books or as a stack of CDs, where once you have a stack of CDs, the element or the CD or the DVD that has been inserted last would be popped out first. So for example, here suppose we take stack as an array, right? So suppose I insert an element 10. So if I want to insert another element called 20, I would insert on the top of 10. So this would become top, right? So now if I insert an element 30, right? So now I've inserted element 30. So 30 would become the top of the stack. So as you can see here, elements are inserted on top of each other. For example, now if I want to delete an element, the first element that would be deleted would be 30, right? 30 would be deleted, and then 20 would be deleted here, and then 10 would be popped out. So now after popping out 30, 20, 10, there will not be any elements basically left in the stack. No elements would be left in the stack. So basically, as you can see, 30, 20 and 10 would be popped out of the stack, right? So we go to the next slide. Here we will see some applications of stack. There are various applications of stack. Some of the applications are undo and redo operations, right? For example, suppose I want to insert a string inside, or I want to type a string inside a word. For example, I would like to type out A, and then I type out B, and then I type out C. A, B, C are inserted in a stack called undo stack, right? Once I press Ctrl Z, so C would be popped out and it would be inserted into the redo stack. So C would be popped out, inserted into the redo stack. I press Ctrl Z again, B would be popped out, and again it would be inserted on top of C, and then once I press Ctrl Z, the A would be popped out and it would be inserted on top of B. Therefore, now as you can see, now the undo stack does not contain any elements, right? It is all the elements are popped out and they are inserted in the redo stack, right? Now I try to redo the elements. A would be inserted again inside the undo stack, B here again, and C here again. Therefore, this is how undo and redo works when we are using Notepad or MS Word. This is one critical application of a stack. The second application is basically function calls. For example, let us take a stack here. Every function is inserted into the stack. For example, first, as you can see this program here, the first function that is called is the main function, right? Main function here, and then A is called here, right? So whenever the main function is called, a stack frame is created for the main function, right? And then there is another function called A here. Now as you can see, from inside the main, A is called. Therefore now here A is called here. This is the A function here, and as you can see, the control goes from here directly here, and inside the A function, B function is being called. Now as you can see, the main function is not executed yet, and the main also is not executed. From the main we call A, and from A we call B, right? So now again the B function is called. So again if a stack frame for B has been inserted into the stack, and then from B the function C is being called, and now again we call C here. We insert a stack frame for C here, right? And inside C we have a print function, we have a print line, some, I'll just say printf and something here, something called inside function, right? So basically once this line is being executed, as you can see, the whole C is being executed. Once this line is executed, the complete C will be executed, and once the C is executed, C is popped out, C is popped out, the C is popped out of the stack. Therefore first the main function is called, and then from inside the main function, the function called A has been called. So we have inserted A on top of main function. So basically this A would become the top of the stack, and from A B was called. Therefore now here B would be the top of the stack, and from B C was called. Therefore C would be the top of the stack. And you can see as we get into C, the whole function, this line has been executed. After this line there is nothing here, therefore C is popped out, which means that the memory is freed for C. And from where was C called? C was called from this function called B, therefore it returns back to B. And inside B, as you can see, after C there is a line called back to B, therefore back to B will be printed, and after being printed the whole B is executed, therefore the B function is popped out here, and memory is freed for B function. As you can see, after execution of B, B was called from A, therefore it returns back to A here, it returns back to A. So from C, after C it returned back to B, and after execution of B it has returned back to A. There is actually one line left after B, so basically here it returns back to the line after the B function, right? So basically here in A, back to A will be displayed, and then after executing that line the whole A is executed, right? Therefore after execution of A, this A function would be popped out, and we can write A here, right? And A was called from the main function, so it returns back here, and there is something called return 0, and then here main also is executed, therefore main also will be popped out here. Therefore as you can see here, we have used stack to insert every function one above the another, and then after completion of all the functions, and after execution of all the functions, each and every function is being popped out of the stack, and you have an empty stack here. Therefore memory is freed for the whole program. Therefore this is one critical application of stack, that is nothing but function calls. We would see recursion is the most important, I think, application of a stack, right? So first I would like to draw recursion as a stack one above the another, and for easier understanding I will draw recursion where I would draw top of the stack one next to one another. Therefore for example, first we all know that the main function would be called first, right? After the main function we have something called int num equal to 4. So we have assigned number as 4. So assignment is always from right hand side to left hand side. For num value would become 4 here, and I'm saying printf factorial of percentile d is percentile d. So this percentile d is related to this num and this to this, right? So I would like to print something as factorial of percentile d is factorial of 4 is, num value is 4, the 4 is factorial of 4. Now here as you can see here there is a function call, so we cannot print anything right now. There is a function call here, so control goes from this line here to directly to this line, this line, yes, this line. And now here as we are passing num value will be stored directly in n. So basically here n equal to 4. Now this factorial function has been called. So as we have seen in the last lecture, as soon as the function is called, the function gets inserted into the stack, right? And then from here we call the factorial function called factorial of 4. So once the factorial of 4 is called, we insert, or factorial of 4 would be on the top of the stack here, right? Factorial of 4, right? Now here as we can see in this program, if n equal to 0, so we all know n equal to 4, n is not 0, therefore it will go to the else statement. Now it is saying here return n into, so basically here return what, 4 into factorial, this is a fact, okay, factorial, okay, let factorial of n minus 1, that is 3. So what is recursion? Recursion is basically a function calling itself. Therefore here function factorial was called, and while executing the factorial function we are calling the factorial function again here from this factorial function. Therefore here 4 into factorial of 3. We all know that once we have a function called, we insert this function on the top of the stack. So again here I'll just say fact of 3 would be called here. Again, for lack of space I'm just writing fact of 3. So again, once fact of 3 is called, here n would become from 4 to 3. Is n equal to 0 and n equal to 1? No. Therefore it will skip if statement, it will come to the else statement. Here I'm saying return n into 3 into factorial of 3 minus 1, that is 2. As you can see, now this would be the top of the stack. Previously this was the top and first this was the top. Therefore right now this is the top of the stack. Right now again factorial 2 is called, correct, factorial 2 is called. Therefore now again n would become now 2 here. Now we insert this function factorial 2 on top of this stack, right, top of this stack. Right now therefore 2 into factorial of 2 minus 1, that is 1. Again factorial of 1 is called here again, right, factorial of 1 is called. Now again we insert factorial of 1 on the top of the stack, right. Therefore here this is nothing but, now again once factorial of 1 is called, as you can clearly observe that n would become 1 here, and then what will happen if n equal to 0 or n equal to 1. So whenever you're using or here, either of these conditions should be true, right, one of these conditions should be true. Here n equal to 1 is true, therefore this whole condition becomes true, this whole condition becomes true here. I just delete this whole condition becomes true, and then we say return 1. Now this is very important. This is called the base condition. Base condition, what does this base condition means? Which means that once I say return 1, it means that the base condition or the base case has been executed, and this will be popped out of the stack, and 1 would be returned where, to the function which called it, right. So which function called it? This one called it. Therefore in place of factorial 1 I have 2 into 1, that is nothing but here, that is nothing but 2, right. Now I'm saying here what I have 2 into 1, that is 2, right. Therefore the whole value is now 2. Now here I am saying here this is basically 2 into 1. So I am saying return 2 into 1. So basically this is nothing but return 2, right, return 2. Where will it return? To the function which called it, right. So which function called it? This one called it. So 2 will be returned here. So this is nothing but, again it becomes return 6, right, return 6. Where should I return 6? To the function it called it. So 6 would be returned here, 6, right. Now here 6 into 4, 24. Therefore return 24. Where should I return? Return to the main function. So basically 24 would be returned here. Therefore it would print factorial of 4 is 24. So for factorial of percentile d represented by 4, and this percentile d format specifier is represented by 24. Therefore it would print out factorial of 4 is 24, correct, 24. And then as you can see, whenever it returns, this is very important point, whenever it returns, this function is popped out. Whenever 6 is returned, this function is popped out. Whenever 24 is returned, this function is popped out. So what did we do first here? We called the main function. From the main function we call factorial. So factorial was inserted on top of this main function, right. And here after this, I'll just delete this top of the stack. Now the top of the stack is this, right. So I'll just revise one more time. First the main function was called, and then inside the main function we called factorial 4. Factorial 4 was inserted on top of the main function, so this became top, right. And now from inside and from inside factorial 4 we called factorial 3. So factorial 3 was inserted on top of factorial 4, right? From factorial 3 we called factorial 2. Factorial 2 was inserted here. From factorial 2 we called factorial 1, and then factorial 1 was inserted on top of the stack. Once we encounter this base condition, automatically basically after return it returns 1, and then this factorial 1 is basically popped out of the stack here, and it comes back and it returns to the function which called it. What called it? Factorial 1 called it. Therefore I replace factorial 1 by 1. Therefore 2 into 1 return 2. See, once it returns, what is happening? Once it returns, the whole function is getting executed. Once this is executed, the whole function is getting executed. That is the reason we are able to pop this function. Therefore after I say return 2, the whole function is popped out. Factorial 2 is popped out. So very important point is that until and unless a function is executed, that function is not popped out of the stack. Once the function is completely executed, only then the function is popped out of the stack. Here as you can see, return 2, 3 into 2, 6, return 6. Where would I return? I would return to the function which called it, that is factorial 3, and then I pop out factorial 3 here again. So here I pop out factorial 3, and then here 6 into 4, 24. So return 24. After executing the return statement, the whole function is executed. So I pop out basically factorial 4, and then here 24 is returned to this line, right? This line, factorial of num, this called it. Therefore here, after printing the statement, after the return 0, after this whole main is executed, then the main function is popped out here. Correct? So this is one critical example of stack, or you can say this is an application of recursion, is an application of stack. Therefore we have seen 3 applications, right? First one would be our undo and redo. Second one would be functions, right? Functions. And third would be recursion, right? So these are the 3 applications of stack till now that we have seen. Okay, one easy example of a stack is reversing a string. Suppose I take my name, so I insert K here, on top of K I insert E, on top of E I insert N, and then Y. So this would be the top of the stack. So if I want to pop out, I'll pop out Y first, and then I'll pop out N, I'll pop out N here, I'll pop out E, I'll pop out K. So reverse, I'll pop out K here. So reversing a string is also one important application of a stack, right? So these are the 4 applications of a stack. So I'll list out again. The first one would be undo and redo. Second one would be basically your function calls. Third one would be your recursion, and fourth one would be your reversing a string, right? The next application would be conversion of expressions. The fifth application would be there are many applications, but we will stop at 5 applications of stack. So this is an infix expression. Expression can be expressed in various ways. This is an infix expression where you have A is called a operand 1, B is called operand 2, and this is called a operator. This is where whenever there is an operator in between 2 operands, that is nothing but a infix expression. Infix, in means that the operator is there in between operands. Now I have plus AB, prefix, which means that the operator is before operand 1. So A is operand 1, B is operand 2, and plus is the operator. Prefix, which means that operator is before operand 1. Here you have operand A is operand 1, B is operand 2, and plus is operator. So postfix, which means that operator is after the operand 2. Therefore conversion of expressions, or we use stacks to basically convert from infix to prefix, infix to postfix. We also convert from prefix to infix and postfix to infix using stacks. Therefore this is also one critical application of stacks. Therefore conversion of infix to prefix, infix to postfix, prefix to infix, postfix to infix, we will in detail look at the upcoming videos. So this would be the end of video 1, where we have discussed about introduction to stacks as well as some applications of stacks, right? Thank you.